Okay, so here is the next section, chapter 2 of rational expressions. Today we're going to be looking at adding and subtracting rational expressions. Yesterday we did multiplying and dividing and looking at non-permissible values. So let's get into this. Remember, with adding or subtracting fractions, what you need to do is you need to make sure that your denominators are the same. If your denominators are not the same, you cannot combine them. So for instance, here we've got 1 over 6 plus 5 over 6. Denominators are the same, so I can say add the tops, leave the bottoms the same, and simplify. Always simplify. So we can do another one. 1 over 5 plus 3 over 5. Add the tops, you get 4 over 5. Not too bad. What happens if the denominators are different? So suppose I give you this. I need to make sure the denominators are the same. So I'm going to take this second fraction and do 4 over 4, basically just the denominator of the other one, and this one 5 over 5, and multiply it into the fraction. This will give me, so 5 times 3 gives me 15, over 5 times 4 gives me 20, plus 3 times 4 is 12, over 20. Same denominator, I can combine them. So 27 over 20. And there's my final answer. So not too bad. You might see some cases that look like this, where you don't need to multiply the denominators on either side. I can just take this and go times this by 2 over 2 to get 8. So sometimes you don't have to do anything. We can also do the same thing now with rational expressions. So if I give you something like this for A, what you can do is, well, the denominators are the same, so I can just simply combine them. So add what's up top. So 5y plus 7y, that will give me 12y over 2x. Don't forget we need to simplify, so I can take 12 and 2, I can factor out a 2 from that, or just divide out a 2. I get 6y over x. So there you go. Again, we could talk about non-permissible values. I can't have an x in the denominator, or 0 in the denominator, so x cannot equal 0. Just to remind you that this still exists even though we're in chapter 2. Let's look at this example here, where my denominators are not the same. So I can still do the same method with this and make these the same. I have an x in both denominators, so I don't need to touch that. And then a 3 and a 2. So the numbers that are down here I need to make the same. So I'm going to times this by 3 over 3, times this by 2 over 2. So we would get 4 over 6x plus 9 over 6x. Now my denominators are the same, and I can combine. So 13 over 6x. So there you go. That's your answer for that. Not too bad. But what about if we've got some more complicated numerators? Let's try f. So this one, my denominators are the same, but I need to combine what's up top. So all of this is going to go over 2x, and I'm going to have x plus x by combining the like terms, so 2x, minus 2 plus positive 3 gives you plus 1. So this is my final answer. Please do not cancel out the 2x's in here. You cannot do that because there's a plus. If it was 2x times 1, then I could cancel it out. But since there's an addition, you cannot just cancel out something in the middle there. That doesn't work. How about something like g? So I need to make these denominators the same. I've got 2x and I've got x squared. So in order to make these the same, I'm going to turn it into 2x squared. So times this by 2 over 2, times this one by x over x. That way I get the same denominator. So let's multiply this in. So I get x squared minus 2x all over 2x squared plus 2x plus 16 all over 2x squared we can combine these fractions together. So put them over the same. X squared, there's no x squared here, so I get x squared minus 2x plus 2x, so those cancel out, plus 16. So there you go. That is going to be your final answer for this. Subtracting is going to be the exact same. There's really nothing that's much different with this. You just might get some negative answers at the end, but it's really going to be the exact same. Let's get into some more complicated ones because you've already seen the easies. So let's take this one. Again, to make them the same, I want to turn it into 6. So times by 3 over 3, times by 2 over 2. By expanding this, I get 2x minus 4 over 6 minus 3x plus 9 over 6. Not too bad. Be careful with this, and where the tricky part is with subtracting fractions, is this minus applies to both terms. So it's minus 3x and it's minus 9. So be very careful with that. That could be a trick with this. So 2x minus 3x gives me minus 1x, or just minus x. Minus 4 minus another 9 gives me minus 13. So there's my final answer. Not too bad. Let's try some here with some trickier denominators. So one like this, something that I always do with this is you can imagine 2x as 2x over 1. That might help you to remember that there's actually a denominator in there. So to make these with the same denominator, I just need to times this one by x minus 8 over x minus 8. Again, we're making the denominators the same so I can combine them. If the denominators are not the same, I cannot divide them, or I cannot subtract them. So I've got 3 over x minus 8, this one didn't change, minus 2x squared minus 16x. And this is all over x minus 8. Like such. Then we can combine these, so you get 3 minus 2x squared plus 16x, because a minus and a minus, over x minus 8. There you go. So that's your answer. Is it ugly? You betcha, but it's all good. It's okay if it's a little bit messy like this. This is still your answer. How about something like C? Your method is the exact same. So nothing has changed with that. I still want to have the exact same denominator in order to make this work. So what I'm going to do is I'm going to time this one by what's in the denominator here. So x minus 1 over x minus 1. Do the same on this side. X plus 3 over x plus 3. You might think, why can I do this? Why can I just multiply something like this? Doesn't that change anything? Well, a number divided by itself is just 1. Or a variable divided by a variable is just 1. So this does work. This is totally okay. So let's multiply this in. 5x squared. Do this so you can see the whole thing. Plus 15x. And this is all over x plus 3 times x minus 1. I'm going to leave this as factored because in the end we might be able to cancel something out. But we need to double check that. So 2x squared minus 2x over all of this, so x plus 3 times x minus 1. Combine everything. So I'm going to put this all over one denominator, like such. Combine this. So 5x squared minus 2x squared gives me 3x squared. 15x minus negative 2x, so that's the same as 15 plus 2x, which is 17x. So there's nothing I can factor out of this to try and cancel anything out. This is just where I'm at. So what I'm... All right, sorry about that. I just had someone walk into the class. So this is not going to be continuous from what you just saw, but we're going to move on from there. So now that I've combined this, I need to do also restrictions. because for now, we actually get some restrictions that are a little bit different. So for this, x cannot equal, and I look back to where everything's factored here. So I cannot have any of these brackets equal 0, so x cannot equal -3, and x cannot equal 1. So those are the restrictions that go along with this to get us what we want. I can look at some a little bit crazier ones. Let's try e here. Oops, I went too far. So for something like this, I'm not going to go through the entire question. If you have something like this, you just need to factor what's on the bottom here. So I'd have 4x, what adds to -9 multiplies to positive 18. So x minus 6, x minus 3, plus this one you can't do anything. So notice I've got an x minus 6 on both of these. So I just need to multiply this one by x minus 3 over x minus 3. And then you'd work out from there. So I'm not going to do this one farther. You've seen a few examples of this. You just multiply this and combine the terms. Just to make the video a little bit shorter this time. So we can use those skills to treat a funky equation that looks like this. So whenever you've got a 1 over something that's all in a fraction, that's just messy. So I want to get rid of this internal fraction in here. So all I'm going to do is I'm going to times the top and the bottom by something that can cancel these fractions out. So in this case, if I multiply both the top and the bottom by x, I get 1 over x times x, just 1. Plus 9 times x, you get 9x. Over 1 over x times x, which is 1, minus 9x. So there you go. That's it. Not too bad. We can try another one here. So this time I've got a 5x in the denominator and a 2x in the denominator. So what can cancel both of those out would be 10x. So I can do that on both of these. So this is going to equal 5 times 10x is 50x. 10 times 2 is 20 divided by 5. 20 divided by 5 is 4. So we got a plus 4 because the x's cancel. Then in the denominator, 10x times 3 is 30x minus 10 times 3 is 30 divided by 2 is 15. So minus 15. And I can do some factoring with this. So I can take out 2 from the top. Get this. I can take out a 15 on the bottom. And this would be the final answer. So I cannot factor anything out. It would just simply be this. So that concludes chapter 2. That one's all done. Again, a recap on this. If you're adding and subtracting fractions, I'll go on to one where you can see it. So if you're adding and subtracting fractions like this, all you're needing to do is make sure that your denominators are the same. And once your denominators are the same, you can combine them and try and simplify as much as possible. So that's going to be the process for that. And that's the end of chapter 2.